Okay, after looking through the lab books, I saw several of the same problems popping up and several of the same concept issues coming forward. So I kind of gave up on that. I didn't score any of them. We're just going to do a quick overview, and then you guys will have the weekend to rework those. Okay, if I start off with a free body diagram, like the AP board loves to make, I would have the tensional force of the string pulling the pig upward, and the gravitational force pulling the pig down. Okay, what I saw a lot of at the time of the presentations was people drawing in the centripetal force. Okay, the centripetal force doesn't get shown on a free body diagram. Centripetal force is not some magical separate force. Centripetal force is any force that causes a circular motion. Okay, so we have to look at the forces that are in existence on the object and decide which one is causing it to move in a circle. Well, it was moving in a circle in the x-plane. Okay, so if it's moving in a circle in the x-plane, there isn't anything acting on it except for tension in the x direction. Okay, so tension in the x direction must be equal to max. Okay, and the acceleration in the x direction is our centripetal acceleration. So if we were to look at sum of forces in the x direction, we have tension in the x direction equals max. So tensional force is also our centripetal force. So this is also our centripetal acceleration. Okay, so Fc equals mac. Our centripetal force is our tensional force in the x direction. So tensional force in the x direction equals mac. Okay, if I drew this off to the side, I would have my tension force, okay, and then I would have my tension in the y direction pointing upward, and I would have my tension in the x direction pointing towards the center. Okay, then if we look at the y direction, summation of forces in the y direction equals, well, we have two things acting on it in the y direction. We have tension in the y direction minus the force of gravity pulling the piggy down, and that is equal to may. Okay, when we watched the pig fly, it popped up and down ever so slightly because of the flapping of the wings, but it stayed pretty constant. So we're going to consider the acceleration in the y direction to be 0. Okay, so that means our tension in the y direction is equal to mg. Okay, if you had weighed the pig, you could have found out the tension in the y direction. I think everybody got that part. Okay, the other thing that came into play though was our tension triangle. Okay, so overall tension, tension y, tension x. If tension x is also our centripetal force, we could have found our centripetal force by accurately measuring that theta, not by guesstimating it, okay, but by accurately measuring our angle theta, or doing some accurate measurements and finding it through trig. That's a good option, right? So now we have theta, we have our ty because that's just the weight of the pig. So we could have found tx by saying tangent of theta equals tx over ty. So now our tension in the x direction equals ty tangent theta, right? Okay, and if that's the case, we now know tension in the x direction, which is also our centripetal force. So that equals tension in the y direction, tan theta. Tension in the x direction was just weight, so now we have centripetal force equals mg, okay, because that was the weight, tan theta. Okay, so now we've solved for the centripetal force. All right, So you could have solved for it that way. You could have solved for it through the alternate route that we discussed before. Okay. The other way is to say centripetal force equals MAC. Okay, to find acceleration, the centripetal acceleration mass, centripetal acceleration is equal to velocity squared over r. Velocity was just 2 pi times the radius, right, over the period. And if we square that and put it over radius, we could have solved through that route. So 2 different routes. Now, the other thing that came up was, why did the piggy take a death spiral? And we had some issues with solving for that. Okay, if I take a top-down view of the piggy's flight, pretend that you've climbed up in the ceiling with all of those awful things that were up there. Okay, and now we have our piggy out here with his little wings. Okay, and he's got his string leading to the center of his circle where he's tied to the ceiling. Okay, so now piggy's flying and he's doing everything that he can to keep going, right? But his poor little motor is only capable of producing so much speed. So he has a set tangential velocity. His tangential velocity is constant. He's powered by 2 AA batteries. There's only so much that those things can put out. And he didn't even have 2 speed settings. He'd had no variable speed settings, so this was constant and unable to be adjusted. So his circular path depends on 2 things. It depends on his tangential velocity, and it also depends on his centripetal force. Okay, if he has no centripetal force, that would be like the strings disappeared, right? And he's just going to take off flying. Okay, well, obviously that's not going to happen. If he has more centripetal force than he has tangential velocity on a ratio basis, okay, if it's excessive compared to his tangential velocity, then his centripetal force is going to cause him to take a death spiral inward, okay, because it starts to outweigh the tangential velocity. And if we look at it from the extremes, like I said, if we took his tangential velocity and just drove it all the way down to 0 so that he's not moving forward at all, his battery shuts off. Okay, if his battery shuts off, that tension, the minute I let go of that piggy, his centripetal force is going to just swing him back in. Okay, so once this is too high in comparison to what his tangential velocity is, he starts to go inward. So if we look at it from ratios, if his centripetal force exceeds that tangential velocity in ratio, he starts to take more and more of a path inward. Okay, it has to be the right proportion between his tangential velocity and his centripetal force in order for him to continue to take that beautiful curved circle. Okay, so his centripetal force depended on his tension in the x direction. So as we lengthened that string, and you guys were trying to give that poor piggy such an amazing ride out there, so now he has this really long string. Okay, if I draw it out looking kind of extreme, but when you think about how you guys flung that poor pig, it's really not that different. Okay, so he's being flung at this huge angle now. Poor piggy has a huge TX, right? He has a huge tension in the x direction pulling him in. And poor piggy, poor little piggy, he still only has his tangential velocity that he's set to. He can't go any faster. He just doesn't have the ability to. His power supply isn't great enough. So now he starts to take his death spiral inward, because when you made this longer and you pulled it out further, and tried to give him a fling and tried to give him that fun ride, it was too much tension in the X direction, right? How about his tension in the Y direction? What happens to that? Okay, his tension in the Y direction, well, did he lose any kind of weight? No, he didn't lose any weight. So he still has the same weight, but now you just increased this tension in the X direction. So his centripetal force is so great compared to his velocity that he just can't keep up anymore, and he just spirals inward. Okay, hopefully that cleared up those two issues. Make sure that you take a look at, if you're unsure, go back and review the first part of the video with the tension and the force of gravity. Make sure that you don't include any kind of separate centripetal force. Remember, it's not magic. As much as I like the idea of Hogwarts, our classroom isn't truly magical. I'm sorry to say that. Okay, but the centripetal force is really just your tension in the X direction, so you can't draw it in there as a separate force. The minute that you add centripetal force as something other than one of the identified forces, the AP board is going to take your points away and break your wand. Okay, so just make sure that you take a look at that. Go back tomorrow, grab your lab books, fix anything that needs fixing over the weekend. This lab took you 2 days plus probably about another half of a class period. The lab's going to be worth a lot more than the typical labs, and I'm hoping that you can make it perfect, because now you have worked it on your own. You've done whiteboard presentations. We discussed it a little bit today in class. I've gone back and done a video presentation, and I'm giving you a chance to rewrite it. We should all be getting perfect scores on this, and this should be a happy thing that pulls your grade up. If it's not, that's because you chose not to fix it. So make sure that you fix it. See you guys tomorrow.